Alright, let's start out with the review from last lesson. So let's take this polynomial and let's divide it by x minus 2 and see what we get. So x minus 2 goes into x to the third minus 4x squared plus 3x minus 1. Alright, so this will go x squared times multiply. I get x to the third minus 2x squared. Subtract all of that. Those cancel. This would be plus 2x. So minus 4 plus 2 would be minus 2x squared. Bring down the 3x. X will go into this minus 2x times. So minus 2x times that is minus 2x squared. Negative 2 times that would be plus 4x. Subtract all of that. Those go away. This would be minus 4x. So I have 3 minus 4, negative 1x. Bring down the minus 1. X will go into this negative 1 times. So negative 1 times x is negative x plus 2. Subtract that. Those cancel. This will be minus 2. So negative 1 minus 2 is minus 3. And you see that my remainder is equal to negative 3. Alright, so we can write that out. P of x divided by x minus 2 is equal to x squared minus 2x minus 1. And we have a remainder of negative 3. So plus negative 3 over x minus 2. And instead of plus negative, I'll just write a minus here. Okay, so let's think about what we have written here. We're saying that this polynomial divided by x minus 2 is equal to this polynomial minus the remainder over that. Okay, so if something divided by something else is equal to this something over here, then it should be true that this side times this equals that. Right? That makes sense, right? If you have 10 divided by 5, that's equal to 2 because 2 times 5 is 10. So if P of x divided by x minus 2 is this side, then it should be true that this side times x minus 2 is equal to that. Right? So if we do that, P of x should equal x minus 2 times this whole polynomial and x minus 2 times this polynomial. Right, so I got one thing minus another. I have to distribute this to both of them. But when I multiply, actually I'll just go ahead and do it. So minus x minus 2 times 3 over x minus 2. Okay, so all I did is multiply both sides by x minus 2. X minus 2 times this polynomial. X minus 2 times that. But of course, those cancel. So I have P of x equals x minus 2 times x squared minus 2x minus 1 minus 3. Is that really true? Is it true that this polynomial is equal to that? Let's check and see. Let's work it back out. So we did division. We got this as our answer. So let's multiply it back and make sure it's really true. So x minus 2 times x squared minus 2x minus 1. And let's see what we get when we do this. So if I distribute here, 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 I get x cubed minus 2x squared minus x. Then multiply the minus 2 times each one of these three. I get minus 2x squared. I get plus 4x. And I get plus 2. Add those up. I get x to the third minus 4x squared plus 3x plus 2. Okay, but remember, we multiplied those, but we also had a minus 3 out here. So we should have a minus 3. So when we combine like terms here, we get x to the third minus 4x squared plus 3x. 2 minus 3 is minus 1. And sure enough, this is what we had originally. Right. All right, let's look at an extremely interesting and useful fact. All right, so we've written this polynomial in this form of this divisor. I think that's called a divisor. This expression on the bottom times our quotient, our answer that we got, plus the remainder out here. Let's find P of 2. P of 2. So I'm going to plug 2 in for x. All right. If I do that, I'll put a 2 here. And I can put a 2 in here. So I'll have 2 squared minus 2 times 2 minus 1 minus 3. 2 minus 2 is 0. And this, it doesn't even matter what it is, so I'm just going to put some mess because I'm going to multiply it by 0. Right? So this will end up being 0. It's 3. So since this is all 0, I get an answer of negative 3. Notice this 2 that I plugged in is this number right here. I had x minus 2. I plugged in a 2. And what happened when I did that was since I plugged in the number that's opposite of this, it caused this to be 0, which canceled that out, which left me with this number. Remember that this number was our remainder. So what happens when I plug the opposite of this number in for x is that I get the remainder of dividing these. Okay, so when I did P of x divided by x minus 2, I got a remainder of minus 3. When I plugged the opposite of this number in for x, I got the remainder. Alright, so we have P of 2 is equal to negative 3, and remember the negative 3 was the remainder that we got when we divided this polynomial by x minus 2. So I'm claiming that P of 2 is equal to negative 3. So let's actually plug the 2 in for the x in the original polynomial and see if we actually get that. So P of 2, if I plug 2 in here, it's 2 to the third minus 4 times 2 squared plus 3 times 2 minus 1. And so that's 8 minus, it's 4 times 4, 8 minus 16, 6 minus 1. 8 minus 16 is negative 8, plus 6 is negative 2, minus 1 is negative 3. And you see that we get negative 3 doing it that way. Alright, let's try another example. So here's my polynomial, P of x, and I'm going to divide by x plus 3. Figure out what that is. So let's come over here to the side. How many times will x plus 3 go into x squared plus 5x minus 4? Okay, so this will go x times, that would be x squared plus 3x. Subtract that. Right, those go away, and this will be 5x minus 3x will be 2x minus 4. So this will go plus 2 times. That will be 2x plus 6. Subtract all of that. Those go away. Negative 4 minus 6 is negative 10. So my remainder is negative 10. Alright, so P of x over x plus 3 should equal x plus 2 plus negative 10 over x plus 3. Let's make sure that's really true. So what I'm claiming is that x plus 3 times x plus 2 minus my remainder should give me that original thing. So let's check it out. So I get x squared plus 2x plus 3x, that's plus 5x plus 6 minus 10. And I get x squared plus 5x minus 4, which is actually what we started with. So we know we got that right. Alright, so I can multiply both sides of this by x plus 3. And I get my original polynomial should equal x plus 3 times x plus 2 minus 10. Which is exactly what we just checked right here. We just saw that was really true. Alright, now just for fun, I'm going to plug in the opposite of this number. So I'm going to put p of negative 3 in here. When I do that, I'll get minus 3 plus 3, and I'll get negative 3 plus 2 minus 10. So I have p of negative 3 equals, this is 0, negative 3 plus 2. Doesn't really matter what that is because it's going to be 0. Minus 10. So p of negative 3, that's 0, is equal to negative 10. Alright, so when I plug in the opposite of this number, when I plug in a negative 3, I get the remainder of negative 10. And let's check and see if that really works. So if I put negative 3 in for p, negative 3 squared is 9. Negative 3 times 5 is minus 15 minus 4. 9 minus 15 is negative 6. Negative 6 minus 4 really is negative 10. Alright, so let's look at this more generally. So say I've got some polynomial and I divide by x minus a. Then I know that I'm going to get some other polynomial, let's call that q for quotient, plus some remainder, let's call that r, and r is just a number in this case, and that will be over x minus a. Okay, so any polynomial that I divide by x minus a, that's always going to equal some other polynomial, and the degree of this polynomial will be 1 less than this one, plus a remainder over x minus a. And this remainder will always just be a number, okay, because your remainder has to be a degree less than this divisor. So a degree less than that would be just a number. Alright, if I multiply both sides of this by x minus a, I get p of x equals x minus a times some other polynomial plus r for my remainder. Alright, if I plug in the opposite of this number, so if I do p of a, okay, so I'm going to put an a in here, so that'll be a minus a times some polynomial plus a remainder. Oh, what's a minus a? A minus a is 0. So p of a is equal to 0 times q of x plus r. Doesn't matter what q of x is because I'm going to multiply it by 0. So that goes away. And I get p of a equals the remainder. Alright, so this is the remainder theorem. It's called the remainder theorem. What the remainder theorem says, if I take any polynomial and I divide by x minus a, then my remainder will be p of a. Okay, so if I take a polynomial, divide by x minus a, if I plug a into this polynomial, I'll get the remainder of dividing p of x by x minus a. Alright, let's try this question. So if I do this polynomial divided by x minus 2, what will the remainder be? Okay, so one way I could work this problem out is I could actually do the division. I could do that long division and I could find out what the remainder is. We could do that, but that takes a while. We could also use the remainder theorem. Remainder theorem says that the remainder of a polynomial divided by x minus a is just p of a. So we have that here. We have a polynomial divided by x minus a. So the remainder should equal just p of a. P is this polynomial on the top. So, and my a is 2. So it should be 2 to the third plus 5 times 2 squared minus 4 times 2 plus 1. And then all we have to do is work that out. So I get 8. That's 4. That's 20. Minus 8 plus 1. 8 minus 8 is 0. So I get 21. So if I did this long division, my remainder would be 21. If you want to do that and check and see if you get it, go ahead. All right, another example. What is the remainder of this polynomial divided by x plus 3? All right, so notice the remainder theorem says that you have to divide by x minus a. But we can rewrite this like this. I have 5x squared minus x plus 7 divided by x minus negative 3. Right? Minus negative 3 is the same thing as plus 3. So now I have x minus a. So my a is negative 3. You don't really have to do this. All you have to understand is that your a is the opposite of this number. So if it's plus 3, my a is going to be negative 3. All right, so the remainder theorem says that if I do a polynomial divided by x minus a, in this case my a is negative 3, then the remainder is p of negative 3. So all I have to do is plug negative 3 into that polynomial. So the remainder is equal to 5 times negative 3 squared minus negative 3 plus 7. Negative 3 squared is 9, so that's 45, plus 3, plus 7. 7 plus 3 is 10, plus 45 is 55. So if I did this, if I did that long division, divided this polynomial by x plus 3, my remainder would be 55. If you want to check that, go for it. All right, let's say we have this function, f of x is equal to that big polynomial. Suppose that you know that the remainder of this polynomial divided by x plus 5 is that big number. Okay, so somebody told you what the remainder was. You were able to figure that out somewhere. So you know the remainder of this division problem. What's f of negative 5? Well, negative 5 means to, f of negative 5 means to plug negative 5 into this function. That would be horribly unpleasant to do without a calculator. I don't want to have to raise negative 5 to the 7th power without a calculator. But we can use the remainder theorem to tell us the answer automatically. I don't have to plug negative 5 in here because I know the remainder of this division problem. So what's f of negative 5? Well, it's negative 221,898. All right, let's make the remainder theorem a little more complex. All right, so say we have a polynomial and we're going to divide it by a constant times x minus a. So by a constant, I just mean a number. Maybe there's a 5 sitting here, or a 3, or a negative 2. So 5 times x minus a, something like that. Okay, so we know if we do this division, we can write it as c times x, c times x minus a times some polynomial plus the remainder. I'm sorry, that's not right. That's not what I meant to write. Okay, if I do polynomial divided by this, I should get some polynomial plus the remainder over c times x minus a. I can write it that way. Then if I multiply both sides by c times x minus a, I'll get a polynomial. It's equal to c times x minus a plus, and the c times x minus a is cancelled. I get the remainder, so I can write it that way. Alright, just like before, if I plug a in here, I'll have c times a minus a plus r. A minus a is 0, so those go away. And again, I have p of a is equal to the remainder. So what this says is that if there's a constant sitting in front of your x minus a, maybe a 5 or a 3 or a 7, some number in front of the x minus a, it doesn't affect the remainder theorem. The remainder will still be equal to p minus a. So we can jazz this up a little bit, and we can say the remainder of a polynomial divided by a constant times x minus a is still p of a. Alright, so one final example here. What is the remainder of this polynomial divided by negative 4x plus 12? Alright, so notice that the denominator here has a GCF, a greatest common factor. So let's factor out a negative 4. So if I do that, I'll have x to the third plus x squared plus x minus 1 all over negative 4 times x minus 3. Negative 4x plus 12. Alright, I want to know the remainder of that. Well, this is just the application of the jazzed up remainder theorem. My constant is just a negative 4, so that's not going to make any difference to my answer. So constant's negative 4, and then I have x minus a, x minus 3. So my a would be 3 in this case. So all I have to do is find p of 3. So I just plug 3 into the top. So the remainder equals 3 to the third plus 3 squared plus 3 minus 1. 3 to the third is 27 plus 9 plus 3 minus 1. 27 plus 9 is 36 plus 3 is 39 minus 1 is 38. So the remainder of that would be 38. If you want to, you can do the long division and check and see if you actually get that remainder. Alright, so I actually did that long division here. There's some nasty fractions in, not very bad fractions, but I worked it out here and see you do get the remainder of 38, so it checks out.